All right, now in this situation, I want to solve this system, and you'll notice that just adding them is not going to do it. Remember, I'm trying to eliminate a variable. And also this time, multiplying by a -1 or just changing the signs is not going to do it either. So what I want to do is I want to think, what variable could I eliminate? And I could see that it's going to be easier to eliminate the y's. Now I have a -2y right here. Think about what this would have to be so that when I added them together, it would drop out. Well, if this is a -2y, I would like this to be a +2y. So what I'm going to do is I'm going to multiply this equation by a -2. Because when I do -2 times -y, I get a +2y, and then that's going to cancel this. I can do that as long as I multiply the -2 times the 7x and also times the -16. So I'm going to get -14x plus 2y equals 32. My other equation I leave alone. I just leave it -4x minus 2y equals 22. Now I can combine these two equations together and the y's will be eliminated. So I get -18x equals 54. And if you divide both sides by -18, we get x equals -3. Then I substitute that back into either equation. I'm going to go into the top equation, and we need to solve for y. So I get -21 minus y equals -16. I'm going to add 21 to both sides. So -y equals a +5. So y equals -5. Multiply both sides by a -1. That's how I get y equals -5. So my solution, -3, -5. All right, here's another one. So I'm going to take a look at both of these, and I'm going to decide, what do I think might be easier to eliminate, the x's or the y's? In this case, I see I have a -2x, and here I have a 12x. So I can see that if I multiply this top equation by 6, I get a -12x, so that it will cancel with the +12x. Now that's not the only thing I could have done, because I could have also, well, you'll see what happens here in a minute. So we have -12x plus 18y, because I have to distribute the 6, and I'm also going to multiply the 6 by the other side, so I get 36. And the bottom equation does not change. Now I'm ready to add the two equations together. When I do, the x's drop out, but look what happens here. The y's also drop out. Now that doesn't mean I'm left with just a blank. I'm left with 0. And over here I get 6. Well, 0 equals 6, that's not true. And when I get a statement like that that's not true, what does that mean? No solution. So what does that mean about these two lines? They must be parallel, because when I have no solution, that means the lines don't cross, which means they're parallel. So remember, this system, if we graphed these, we would say was inconsistent. All right? Next example, we're going to solve the system 9x minus 7y equals 14 and 4x plus 3y equals -6. Well, you can see just adding the two equations won't do me any good because I can't get the x's to drop out or the y's. The other thing is there's nothing I can multiply the 4 by to get it to turn into a -9, to cancel out with that. Also, there's nothing I can multiply the 3y by to turn it into a 7y. Well, I guess I could multiply by a fraction, but there's no whole number that I could do. So what I'm going to do on this one is I need to multiply both equations by something to turn those into numbers that will cancel out. For example, if the first equation, if I multiplied by a 3, and if in the second equation I multiplied by a 7, That's going to give me a negative 21y, and down here I'll have a positive 21y. So when I add the equations together, my y's will drop out. So this becomes 27x minus 21y equals 14 times 3 is 42. And this one becomes 28x plus 21y equals negative 42. So now when I combine the two, oops, I forgot my one. When I combine the two equations together, when I add them, the y's are going to drop out, and I'm left with 56x equals 42 minus 42 is 0, and that's not a problem, because when I divide both sides by 56, I get that x equals 0, and we can get that. So now I'm going to substitute the 0 back in. 9 times 0 minus 7y equals 14. So this is just 0, so we get negative 7y equals 14. So y equals negative 2, which means my solution to my system of equations is 0, negative 2, which means if I graph these two lines, they're going to cross at the point 0, negative 2. All right, you'll see here we have the same kind of situation. Notice that there's nothing to multiply the 2 by to turn it into a negative 9y. There's nothing I can do here in one single move, so I'm going to have to multiply both equations. Now my goal is to make them be opposites of each other. So the x's are already opposites, so I'm going to eliminate the x's by multiplying the top equation by 5 and the bottom equation by 4. So I'm turning them both into 20s, a 20x and a negative 20x. So remember, the 5 gets multiplied by the entire equation, so we have 20x plus 45y equals negative 5. And the second equation changes to negative 20x plus 8y equals negative 48. Now, a common mistake people make is to forget to multiply the constant on the other side. So you'll need to check for that. So my x's drop out, they are eliminated, and I get 53y equals negative 53. So we get y equals negative 1. Substitute into either equation. So I'll take the top. And when I substitute that in, I get 4x minus 9 equals negative 1. Add 9 to both sides, I get 4x equals 8. So x equals 2. And my solution is 2, negative 1. Now let me just make mention here, our answers that we're getting are all integer answers. They're all pretty nice. They don't always have to be, and many times they won't be. In real life, problems are not, when you do word problems, they're not going to be nice numbers that you get for answers, but we're learning the process. So we're learning the process with simple numbers so that we don't get bogged down in the, with more difficult numbers. But we will have situations where they get a little more difficult. Oh, here's one. What do you know? So let's go ahead and look at this, and this just looks like a mess. So before I get started on this, I want to set it up so I can do something with it. Now the first thing I'm going to do on this first one is, you know me, if I see fractions, then I'm going to do fraction busters. So I'm going to start by looking at the denominators. I'm going to multiply everything by 6. So when I do that, I get 6 times 0 is 0. I'll have a negative 6y. The 2 cancels with the 6, leaves a 3. And 3 times 9 is 27, so it's going to be minus 27. The 6 cancels with 6, leaves a 1, minus 5, or times the 5, so we're going to have a minus 5x. So at least that's a little better, but I'd like to reorganize that so it's in standard form. So I'm going to add the 5x to both sides. So I'm going to put a 5x over here. I'm also going to add a 6y. So when I rearrange these terms, I'm going to have 5x plus 6y equals negative 27. Now I'm going to rearrange these two so that they all kind of match up. So if I subtract 6x from both sides, and add the 4 to both sides. So I get a negative 6x plus a 7y equals 4. Now I'm set up and ready to go. So I had to do a little bit of work with that to make it a little simpler, so that now I'm going to pick up where I would next, where we in the previous problem. So I'm going to multiply this by a negative 6, and I would multiply this by a positive 5 to make my x's drop out. I'm going to write them underneath. I'd get negative 30x minus 36y equals 162. And here we have, oops, I should have done this with a positive. Let's change these. I'm going to change that to a positive because I want these to drop out. So now we have a negative 30x plus 35y equals 20. And now my x's drop out. I get 71y equals 142. Make that a negative 142. And from there we get y equals negative 2. Nice little answer. And then we can substitute that back in. Let's substitute that into this equation right here. 7 times negative 2 minus 4 equals 6x. So we have negative 14 minus 4 equals 6x. So negative 18 equals 6x. So x equals negative 3. So our solution, negative 3, negative 2. So the trick on that is just to use fraction busters, get it into a form you can work with.